The objective of this lesson is to use a number line to model positive and negative numbers and determine relationships of numbers in real-world applications. In a previous lesson, students learned that rational numbers include integers, which are whole numbers and their opposites. Let's create a number line that shows integers. Positive numbers are written equally spaced to the right of 0. Positive numbers can be written with or without the plus sign. It means the same thing. And the arrow at the end of the number line shows that these numbers go on forever to the right. The negative numbers are written equally spaced to the left of 0. The negative sign must be written to show that they are opposite of positive numbers. And again, the arrow pointing to the left means the negative numbers go on forever in that direction. The number line helps us see numbers in relation to each other. As we go to the right on the number line, the numbers get larger. As we go to the left on the number line, the numbers get smaller. So we can see that 2 is less than 4 and negative 4 is less than negative 2. Because integers do not contain fractions, the rational number system was introduced. Rational numbers are any negative or positive numbers that can be written as a fraction, such as 1/4, negative 4, 1 2/3, negative 4.5, and negative 2 3/8. The number negative 4 is rational because it can be written as a fraction, negative 4 over 1. The decimal, negative 4.5, is also a rational number because it can be written as the fraction, negative 45/10. Let's put these numbers on our number line. 1/4 is greater than 0 but less than 1. If that section is divided into 4 equal parts, the dot will be placed on the first division to equal 1/4. 1 2/3 is larger than 1 and less than 2, so the section needs to be divided into 3 equal parts, and the dot will be placed on the second division to show 1 2/3. Negative 4.5 is less than 0 and halfway between negative 4 and negative 5, so the dot will be placed there. Negative 2 3/8 will be less than negative 2 and greater than negative 3. 3/8 is a little less than 4/8, which would be the same as 1/2, so the dot will go less than 2 and a little less than 1/2. Negative 4 is easy because it is less than 0 and the negative 4 is already marked for us. Now it's easy to see where each number fits in relation to the other numbers. Negative 4.5 is less than negative 4. 1 2/3 is greater than negative 2 3/8. A real-world example would be a timeline displaying the years that each country will host the Olympic Games between 1996 and 2020. Notice that the Olympics are held every 2 years, and we will only label those years. Let's draw a number line under the timeline and label the current year 0. We want to find out how many years away from 2016 a country is a host. The positive numbers tell us how many years in the future a country will host the Olympic Games. The negative number tells us how many years in the past a country hosted the Olympic Games. From our timeline, we can see that Russia hosted the Olympic Games 2 years ago because the number line shows a negative 2 under 2014 when Russia was the host. In 2020, Japan will be the host, and the number line shows that it will be 4 years from now. When was the last time the United States hosted the Olympic Games? Yes, the number line shows negative 14, so it was 14 years ago, in the past. Our objective in this lesson was to be able to use the number line to model positive and negative numbers and determine relationships of numbers in real-world applications. We met this objective by first learning how to create a number line with positive and negative numbers, then compared numbers on both sides of 0, and then showed examples of how it was useful to us in real life.